Hello, my name is Archie from Year 7H of League Class 2024. Today, I'm going to be showing you the three laws of motion discovered by Sir Isaac Newton in late summer of 1666. I'm going to be showing you the three laws of motion using these examples. The law of inertia, I'm going to be using for this toy car to represent the law of inertia. This soccer ball, I'm going to be demonstrating you the law of acceleration. I'm going to be using my own body to represent the law of action and reaction. I'll be showing you how non-contact and contact forces affect our daily lives, such as walking and driving. This ball is going to represent the non-contact force of gravity, and I'm going to be using my body again to represent the contact force of friction. I'm going to be demonstrating one of the laws of motion known as inertia. Before I apply force to this car, this will remain stationary, which relates with Newton's law of inertia, that for every object it will remain stationary unless another external force will act upon it. I'm going to be demonstrating you the second law known as the law of acceleration. Before I start to kick, I'm going to show you two different variations of how I kick. For the first one, this is a hard kick, meaning the force that I apply to this ball will be much greater, that will result in a great acceleration. As you can see, the ball goes really fast. For the second one, I apply less force to the ball, and look what happens. It goes slower than the first one. Meaning, if you apply more force to a ball, it will go farther and more faster, while if you put a weaker or less force, it will go slower and more easier to catch. I'll be demonstrating you the third law, the law of action and reaction. For this, I'll be using my body to explain this. As you can see, I'm going to use my legs to exert force onto the ground, which the ground will exert force back, creating a reaction from the action I created. The more force you apply to the jump, the more high you get. And if you happen to be on the moon, since the less gravitational pull that brings you down, you have a more higher jump height. Meaning, like Neil Armstrong, the reason why he was able to go really far high is because when he did a small jump, like this, the moon's gravitational pull is far weaker than the one we have on Earth, which brings us down. Therefore, for Neil Armstrong, he flies to a bit more higher than, about 6 times more higher than the jump height in Earth. For the last, I'm going to be demonstrating contact and non-contact forces. First, I'll be showing you the non-contact forces, which is gravity. As you can see, this is a paper and a ball. Which do you think will go farther down from gravity? From the ball, what we can see, the ball goes down faster and we should drop than the ball, than the paper. Now I'm in a much higher place. From this, what we can see from the first demonstration is that this ball is weighed much heavier than the paper. Gravity attracts two objects with masses, and with a greater mass, the more likely they go down faster than the one with lesser mass. For this demonstration, I'll be showing you a contact force known as friction. It occurs when two surfaces are in contact with each other. As I rub my hands, I'll be experiencing a thermal energy caused by my hands rubbing each other. As I progressively rub my hand, it progressively gets warmer, caused by the friction between my hands. And as I stop, the friction goes away.